Let's see how nimble CAEPIPE really is. In this video, we will examine a model that has huge moments at the anchor at node 214 in the operating case. Using some of CAEPIPE's Nimble features, we will try to reduce the moments at the anchor. Here's the graphic display of our model. This is the area that we will be working with. This is where the maximum loads reported are, at the anchor at node 214. To lower these loads, we will focus our efforts at this bend here at node 407, as well as this T-section at node 351. The operating case is sustained and expansion cases combined. As you can see, we have two high moments due to temperature and one high moment due to weight. Let us reduce these by adding supports. First, we will tackle the sustained case by studying the deflected shape. You can see where the sustained case displacements are. The deflection is happening right here. The first thing we want to do is to try to stop the displacement at node 407. We will add a limit stop here at 407A. We find node 407. We create 407A. And we put in our limit stop. We leave the upper limit blank, and the rest of the default settings are fine. Surprisingly, the support at node 407A reduced the moments not only in the sustained case, but also in the expansion case. But we still need to reduce my in the temperature case. So let's look at the best place to add another support. Here we see the deflected shape. Looking at the animated deflected shape, it seems that this section here at node 351 could use a support. I think a limit stop along the x-axis would work well in stopping the deflection. Now let's locate node 351. And let's add a limit stop. The upper limit has to be 0 because we want to stop the movement along the plus x-axis. We leave the lower limit blank. Also, we make the x component 1. We change the y component to blank. Now let's reanalyze and take a look at our model. This lateral support did not work. What if we replace the first support with a guide? And take out our limit stop. Now let's try a different solution. How about if we change the one-way limit stop at node 407A into a guide in order to limit the displacement along the x and y axis simultaneously? So we go back to 407A. And we change the limit stop to a guide. Looks like all the default settings are okay. There you can see our guide. Now let's analyze again, and hopefully this has solved our problem. One guide takes care of all high moments, and it took us less than 30 seconds to find out. To summarize, here's what we did. To reduce the excessive support loads in the operating case, we found that we had to reduce the mx moment in the sustained case and the mx and my moments in the expansion case. We tried a couple of ideas quickly inside CAEPIPE. First, we reduced the mx moment in the sustained case by adding a vertical support near the anchor. Then, we found that adding a lateral support at a nearby t made the expansion moments worse. Therefore, we changed the vertical support to a guide, which reduced all three moments to manageable levels. CAEPIPE's rapid input, analysis, and results review procedure allowed us to quickly realize that only one support was needed to solve both sustained and expansion cases. This makes CAEPIPE an ideal tool to run what-if situations and optimize support configurations.